One of the important factors that define the flexibility and maneuverability of robots is degree of freedom. And some students often make a mistake in counting the number of links and joints. So in this video, I decide to provide an explanation to avoid making mistake. If you enjoy this type of content, please subscribe my YouTube channel. As you can see, we have two distinct equations that give you a same result. It's up to you to decide which one of them to use. Personally, I prefer the first equation. And as you can see, we have a total of 5 parameters. In both equations, we have a parameter named m, which represents the maximum degrees of freedom in either planar robot or a spatial one. If you are working with two-dimensional workspace, this value is equal to 3. And if you are working in three-dimensional workspace, we have a 6 degrees of freedom. Additionally, there is another parameter called n, and which represent the number of links in mechanism. It's important to note that when counting the links, you should include the ground as a one link. Furthermore, we have a parameter called j, which indicates the number of joints. Each joint has a 2 distinct number associated with freedom and constraint. For instance, in two-dimensional workspace, a revolute joint actually permits the rotation of a link around the axis while constraining the joint from moving along to other axis. So f parameter is equal to 1 and constraint parameter is equal to. As I told you, since it permits our link to rotation around one axis and constraining this link from moving along to other axis. Okay, to enhance our understanding, let's work through some example. In the first example, we have a mechanism where both sides are connected to the ground. And as I mentioned before, I prefer using the first equation. It is our first equation. And now we need to identify 3 parameters: m parameters, n parameters, and constraint. And here, okay. N is the number of link and constraint. Okay, our m parameter is equal to 3, since we are working within a two-dimensional workspace. In the provided mechanism, you can observe a prismatic joint. Actually, when you encounter a joint, there are at least 2 links associated with it. For example, it is prismatic joint and you have at least two links. If you see this revolute joint, you can see 4 links that's connected to this revolute joint. When we considering both sides of this mechanism, which are connected with the ground, you should count them as a single link. I wanna identify the n parameter. As you know, n parameter is the number of links. I wanna count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we have 20 links, and as I told you, we should count a ground as a single link. I know that this mechanism connected to the ground in both sides, but we count both sides as a one link. So we have 21 links. And in the next step, we should count our joints. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 prismatic joints. Okay. Then we wanna count our revolute joint. 1, 2, 3, 4, 5, 6, 7, 8. 8 revolute joint. But stop here. At first glance, you may observe 8 revolute joints in this mechanism. However, when you look at more carefully, some of these joints actually connect more than 2 links. For example, here, it's connected 4 links together, and here it's connected 3 links together. Consequently, we need to evaluate our count. There is useful formula to determine the number of required revolute joint. The number of links minus 1. For example, if here we have 4 links, 4 links minus 1 give us 3 revolute joint is equal 3. So in here we have a 3 revolute, in here we have a 3 revolute joint. So we count revolute joint again. Okay, in here we just have a 2, and this revolute joint just connects a ground to 1 link. So in here we just have a 1 revolute joint. But here this revolute joint connect 2 links to 1 ground. So here we have a 3 links. 3 links minus 1 is equal to. So here we have a 2 revolute joint. In here we have a 4 revolute joint, 4 links that give us 3 revolute joint. In here we have 3 revolute joints, 3 revolute joint, 3 revolute joints, and here we have a 1 revolute joint, but here we have a 2 revolute joint. So as I told you, we don't have a 8 revolute joint. Now we have a 3, 3, 3, 3, 12, and 12, 2, 2, 2, 6. So 12 plus 6 is equal 18. And 18 plus 9 is equal 27. So we have 27 joints. But it doesn't mean that the constraint number is equal 27. Actually, we know that we identify constraint from this formula. Actually, we know that we have 9 prismatic joints. As you know, a prismatic joint allow you to move along one axis. But it constrains you to, and it doesn't allow you to move along another axis and rotate around one axis. So you don't have it to another freedom. And in here, you know that we have a 18 revolute joint. That in the revolute joint you can't move along 2 axes, so it constrains you to don't have a 2 degrees of freedom. So in here, I wanna write the equation. Okay. Three multiply 21 minus 1 is equal 20, and minus 50, 56, 54. No, sorry, 54. 54, yes, and 60 minus 54 is equal 6. So in this example, we have in this structure mechanism, we have 6 degrees of freedom. Okay, in the next example, let's begin by identifying 3 parameters. M parameter, N parameter, and C parameter. As you see, we have a planar mechanism, so the number of M is equal 3. And in the next step, we should identify the number of links. 1, 2, 3. All of this is a one link. 4, 5, and actually here we have a revolute joint that connected this link to a slider. So here a slider is a link. And in here we have another slider. So we have a total of 7 links. However, as I told you before, we should consider a ground as a one link. So the number of link is equal to 8. And in the next step, for identifying the number of constraints, we should recognize the type of our joints, and then the number of constraints. Here we have 1, 2, 3, 4, 5, 6. We have 6 revolute joint. Then we have 2 prismatic joint. Then at the end we have 1 fork joint. Actually, as you know, the fork joints allow you to rotate around one axis and move along one axis. So we identify the number of constraints for each one of them. Actually, as I told you before, revolute joint gives you a 1 freedom, so it gives you a 2 constraint. And prismatic joint gives you a 1 freedom and gives you a 2 constraint. However, fork joint gives you a 2 freedom, so we have a 1 constraint. So we multiply these numbers. 12, 4, and 1. We plus all of them. So the parameter C is equal 17. So we wanna write the equation. 21 minus 17 is equal to 4. Okay, so in this mechanism, we have a 4 degrees of freedom. In our last example, we are dealing with a special mechanism, which means our n parameter is equal to 6 in this case. So we should we write our parameters and the n parameter, which means the maximum number of degrees of freedom, that here is equal to 6. And in the next step, we should identify the n parameter and c parameter. In this type of question, actually recognizing the joints before the links, before counting the number of links, make the problem much easier. So in this case, we should identify, in the first step, we should identify our joints, our type of joints. Here we have a revolute joint. Here we have we have a joint that allow us to revolute about 2 axes. So we have a universal joint, and in here we have a prismatic joint, and in here again we have a universal. Now we can count the number of links much easier. As you see, we have a revolute joint here, so it's connected at least 2 links. In here we have 1 link, in here we have our first link, and here we have our second link. And our second link, this entire shape actually includes our second link that's connected with a slider. So here we have our third link, and our third link connected with prismatic joint to another link. So we count a total of 4 for our links, and here we have 5, 6, 7, and this entire shape 8. So we have 8 links. Maybe you should think that we should include a ground, and we should +1 that represents our ground. But just for 1 second, look at here. This is our link. This is ground. But in this case, there is no identifiable joint connecting these links to the ground. Therefore, we consider the ground as a part of our mechanism, and we have already included it earlier in our analysis. So in the next step, we write our type of joints. We have 2 revolute. We have 4 universal, and we have 2 prismatic joints. in the planar workspace, our Revolut joint actually limit us in just 2 degrees of freedom. A Revolut joint gives us 1 degree of freedom and limits us in another 2 degrees of freedoms. But here we have a spatial workspace, so our Revolut joint give us 1 degree of freedom and limits us in another 5 degrees of freedom. And universal here limits us in 4 degrees of freedom, and prismatic joint limit us in 5 degrees of freedom. So we ten, 16, 10, 6, 36, and we write again the equation. Six, we have 6 degrees of freedom. So in this example, we have 6 degrees of freedom. Our mechanism have a 6 degrees of freedom.